Assalamu alaikum students. I hope you all will be doing well. In the previous lesson, we have studied that noble gases are inert and stable, and all other atoms tend to attain the noble gas configuration by either having 2 or 8 electrons in their valence shell. Now in this lesson, we will study that what is duplet rule and octet rule and what are some exceptions of octet rule. First of all, what is octet rule? Attaining of 8 electrons in the outermost shell either by sharing, losing or gaining electrons is called octet rule. This octet rule only symbolizes that noble gas electronic configuration should be attained by the atoms when they are combining with each other or when they are reacting with each other. Octet rule plays a significant role in understanding the formation of covalent bond or ionic bond between the atoms. Now, what is duplet rule? The attaining of 2 electrons in the valence shell by either losing, gaining or sharing electrons is called as duplet rule. It is only for those elements like hydrogen, helium, lithium, beryllium which have only S subshell. As they attain the noble gas configuration of helium, so we say that duplet configuration has been attained. For example, lithium has the electronic configuration 2,1. When it loses its 1 electron from the valence shell, now it has only 2 electrons in the first shell or 1s subshell. Helium configuration has been achieved. Hence, lithium obeys duplet rule when it loses 1 electron to form lithium ion. In the same manner, when 2 hydrogen atoms share their 1 electron, they have 1s2 configuration, that is helium configuration is achieved, and this is called as duplet rule. Now, there are some exceptions to the octet rule. The octet rule fails in many situations involving ionic compounds of transition metals and in many covalent compounds. Those exceptions to the octet rule are of 3 main types. Firstly, the molecules in which an atom has less than 8 electrons in the valence shell. Second, the molecules in which even after the formation of the compound, the atom has more than 8 electrons in the valence shell. And third possibility is that the molecules which have odd number of electrons. Now let us study these 3 cases one by one. The first case is of less than octet. These molecules and compounds are relatively low. Molecules with less than an octet are typical for compounds of group 13. Elements like boron, aluminium, gallium, etc. Most typical example is of boron trifluoride BF3. Now, you must look here that the boron atom which is present in the center of this molecule has only 6 electrons or 3 pairs of electrons around it in BF3. So, boron atom even after the formation of chemical bond with 3-fluorine atom is deficient of 2 electrons as it is having only 6 electrons. So, this is an example of the compounds in which octet is incomplete. Such examples also include AlCl3, GaI3, etc. Now, next case is of more than an octet. This is the largest class of exceptions. Atoms of elements from the 3rd period of the periodic table and onwards can accommodate more than an octet. For example, SF4. Now, in SF4, this is the Lewis structure, and in the second part of the lesson, we will study the Lewis structure. So, for the time being, you must only know that each of this line is representing 2 electrons. So, counting the total electrons of sulfur in SF4 compound, there are 4 bond pair of electrons, means 8 electrons, and there is 1 lone pair of electron on the sulfur atom. As there are 5 pair of electrons around sulfur, so it is having 10 electrons. In such case, we say that expansion of octet is taking place. that the central atom is having more than an octet. Other examples of this category include PCl5, SF6, and we will study these examples after discussing the Lewis structures in this lesson. Last possibility is the molecule with odd number of electrons. Some molecules contain an odd number of electrons because we need an even number of electrons for complete pairing. The octet rule clearly cannot be satisfied for all the atoms in any of these molecules. For example, an odd number of electron is in NO2. Here, the nitrogen atom does not follow the octet. Reason? Because it is having 7 electrons in total. As a result, its octet is incomplete, or we can also say, as 7 is an odd number, that it is the example where the molecule is having odd number of electrons. Now, the exceptions of octet rule can be better considered if we know how to draw the Lewis structures of the molecule. So, what is a Lewis structure? A Lewis structure is a representation of covalent bonding in which shared pair of electrons are shown as small straight line or dash between two atoms, and unshared electron pairs are shown as pairs of dots on individual atoms. Here you must know that only valence electrons are shown in the Lewis structure. Now let us study some examples that how can we draw the Lewis structures. The first example is of ammonia molecule NH3. Now for drawing the Lewis structure, first of all you must decide the central atom. In NH3, nitrogen is the central atom. Here you can see that nitrogen is present in the center and hydrogen atoms are surrounding it. So for drawing the Lewis structure, we must know the number of valence electrons in each of the combining atom. Hydrogen belongs to group 1 of the periodic table, so it has only 1 electron. On the other hand, nitrogen belongs to group 15 of the periodic table and it has 5 electrons in the valence shell. Since it has 5 electrons in the valence shell, the deficiency to complete the octet is of 3. So, out of these 5 electrons present in the valence shell, 3 electrons will be involved in bonding. So, there must be 3 hydrogen atoms which will share 1 electron with each electron of the nitrogen atom. So, in this way, 3 single covalent bonds are formed and the remaining 2 electrons are present as the lone pair on the nitrogen atom. So students, first of all, for drawing the Lewis structure, you must know the number of valence electrons of each atom. Nitrogen belongs to group 15, so it is having 5 electrons, but only 3 electrons will be involved in bonding. Hydrogen atom can form only 1 bond, so each hydrogen will form 1 bond. So it is the possible structure that 3 single covalent bonds are formed and 1 lone pair is present on nitrogen atom. Now next example is Lewis structure of water. Here in water, oxygen atom is the central atom and hydrogen is the surrounding atom. So count the valence electrons first of all. Hydrogen belongs to group 1, so here is only 1 electron in the valence shell. Oxygen belongs to group 16 of the periodic table and it has 6 valence electrons. So total electrons are 6 electrons present in the valence shell, whereas 1 multiplied by 2 since there are 2 hydrogen atoms. So in total there are 8 electrons. Now how many bonds are formed depends upon the deficiency of the electrons in the valence shell. Since oxygen is belonging to group 16, it is having 6 electrons in the valence shell. The deficiency to complete octet means to attain the 8 electronic configuration, the deficiency is of 2 electrons. So out of 6 electrons, 4 electrons will not be involved in bonding, and as electrons are always represented in pairs, so 4 electrons means 2 lone pairs will be present on oxygen atom. Whereas out of 6 electrons of oxygen atom, only 2 will be involved in bonding and each electron will be shared with one of the hydrogen atom. In this way, oxygen atom is surrounded by 4 pair of electrons, out of which 2 pairs are bond pairs and 2 pairs are lone pairs. Hence, the octet of oxygen atom in water is complete, and water follows octet rule because oxygen has octet electronic configuration and hydrogen atom has duplet configuration in this case. Next example is of methane molecule or CH4. Here you must decide that the central atom is of lower electronegativity and carbon is the central atom. Now again count the valence electrons. Carbon belongs to group number 14 of the periodic table. Hence it has 4 electrons in the valence shell. Deficiency is of 4 electrons because when carbon will share 4 electrons, it will have 8 electrons in its shell and its octet will be completed. On the other hand, hydrogen atom is having 1 electron. So total electrons in the valence shell will be 4 electrons of carbon and 1 multiplied by 4 because you can see here in the formula there are 4 hydrogen atoms. So each hydrogen atom is contributing 1 electron. So in total there are 8 electrons or 4 pairs of electrons. This is the Lewis structure of methane. Now why there are all the bond pair of electrons? Because carbon has 4 electrons in the valence shell and the deficiency is of 4 electrons. So when the deficiency is of 4 electrons, it means that carbon atom must share all of its 4 electrons. Hence, 4 bond pairs are formed. Next structure is of AlCl3. Again, first of all, decide the central atom. Here you can see that aluminium is the central atom. Next step is count the valence electron. Since aluminium belongs to group number 13 of the periodic table, it has 3 electrons in the valence shell. On the other hand, chlorine belongs to group number 17 of the periodic table and it has 7 electrons in the valence shell. Since there are 3 chlorine atoms as represented in the formula, so there will be 7 multiplied by 3, and when we will add 3 electrons of aluminium to the electrons of chlorine, there are 24 electrons or 12 pairs of electrons. Now these 12 pairs of electrons are arranged in such a way that aluminium forms 3 single covalent bonds with chlorine and rest of the 9 electron pairs are represented as lone pair on each of the chlorine atom. Students, there is another way of simply that how can you draw that since aluminium is having 3 electrons in its valence shell, the maximum number of electrons which it can share is 3. So each of the chlorine atom will share 1 electron with aluminium and in this way 3 bond pairs are formed. For each chlorine atom, as 1 electron has been involved in bonding, 3 lone pairs will be present on each of the chlorine atom. Now you may observe here that the octet of chlorine is complete, but the central atom aluminium has incomplete octet. Hence it is an exception to the octet rule AlCl3 where the central atom is having incomplete octet or less than octet. Next example is of BF3, as we have discussed it earlier in the exception as well. Here the central atom is boron and there are 3 fluorine atoms surrounding boron. Again, boron belongs to group number 13 of the periodic table. It is having 3 electrons in the valence shell. So the maximum number of electrons which it can share with the surrounding atom is 3. Since there are 3 fluorine atoms, so what will be the possibility that boron shares 3 electrons separately with 3 fluorine atoms. Hence, what will happen that the Lewis structure is that boron is forming single covalent bond with each of the 3 fluorine atoms, and on the other hand fluorine, although it has 7 electrons, but it has only 1 electron involved in bonding. So 6 electrons are left and 6 electrons are represented as 3 lone pairs on each of the fluorine atom. Next example is of PCl5. In PCl5, phosphorus is the central atom. Now you must know that phosphorus belongs to group number 15 of the periodic table. As a result, what will happen that it has 5 electrons in the valence shell. On the other hand, chlorine belongs to group 17 of the periodic table. It has 7 electrons in the valence shell. So count the valence electrons, 5 electrons of the phosphorus and 7 multiplied by 5, 35 electrons of the chlorine atoms. In this way, there are total 40 electrons or 20 pairs of electrons in PCl5. But remember students, not all the electron pairs are present on phosphorus. Phosphorus has 5 electrons and it has to form bonds with 5 chlorine atoms. So what's the possibility that phosphorus forms 5 single covalent bonds with each of the chlorine atom? Since chlorine atoms only involve 1 electron out of 7 in sharing, so 6 electrons are left on chlorine, which are represented as 3 lone pairs on chlorine atom. Now here you must observe that the octet of chlorine is although complete, but the central atom phosphorus has 5 electron pairs, particularly bond pairs around it. 5 multiplied by 2 means 10. So PCl5 is an example of expansion of octet because it is having more than 8 electrons in its shell. Last example is Lewis structure of SF6. Now first of all decide the central atom. Here the central atom is sulfur and sulfur has to form bonds with 6 fluorine atoms. Now sulfur belongs to group number 16 of the periodic table. It has 6 electrons in the valence shell. Each of the 6 fluorine atom has 7 electrons in the valence shell. So if we have to count the total number of electrons, 6 electrons of sulfur and 7 multiplied by 6 electrons of fluorine. In this way, total 24 pairs of electrons are present. Now, listen carefully that sulfur has 6 electrons in the valence shell and it has to form bonds with 6 fluorine atoms as indicated in the formula of the compound. So what's the possibility? That each electron out of 6 electrons of sulfur is shared by 1 electron contributed by each of the 6 fluorine atoms. So in this way, 6 single covalent bonds are formed, 6 bond pairs are formed, and rest of all the 18 pairs are lone pairs. Each fluorine atom is having 3 lone pairs of electrons, and as there are 6 fluorine atoms, so 18 pairs of electrons are in the form of lone pairs, non-bonding electron pairs, and there are 6 bond pairs of electrons. So students, if you know the Lewis structure of the compound, then you may easily have the idea that whether the octet rule is followed or not. Like here, sulfur is having 6 pairs of electrons around it, 6 multiplied by 2, 12 electrons. Hence, it is also the example of expansion of the octet. So, Lewis structure helps in determining the bonding and the number of bond pairs and lone pairs in the electronic structure, and we can predict that whether the molecule follows the octet rule or it does not follow the octet rule. Lewis structure will also be discussed in covalent bonding, and then you will have much better idea that how easily we can draw the Lewis structures of different compounds. For the time being, you just have to understand those Lewis structures where the octet rule is followed or whether the octet rule exceptions are discussed. Thank you students. Allah Hafiz.